The purpose of this video is to identify and give a brief description of the convection blower system components installed in the Alto-Shaam Converge oven. We will be using this pictorial layout diagram to explain the convection blower system. This diagram is based off of Chamber 1 from a 208-240 volt Converge oven. The diagram is subject to change, and the electrical schematic should always be used for actual electrical connections. To build the diagram, we will start with the main disconnect. Electrical power comes into the oven at the disconnect switch, located in the back right corner of the electrical chassis. The load side of the disconnect switch is connected to the terminal blocks mounted on the DIN rail at the left side of the electrical chassis. Each of these terminal blocks, identified as TB1, TB2, and TB3, consist of two different sized blocks jumpered together to make one block. Mounted on the DIN rail next to the terminal blocks are circuit breakers CB1, CB2, and CB3. These circuit breakers supply one leg of line power to the convection heating elements in the oven. Mounted forward of circuit breakers 1, 2, and 3 are circuit breakers 4 and 5. These circuit breakers supply electrical power to the control circuits and the DC power supply in the oven. On the outside of the oven is a removable panel to be used for resetting the circuit breakers without having to open the top of the oven. It is a good practice before performing any troubleshooting on the oven to open this panel and reset these circuit breakers. Connected to the load side of circuit breakers 4 and 5 are terminal blocks TB16 and TB22. Mounted forward of the TB16 and TB22 is the CV drive relay. When this relay is energized, it enables all of the variable frequency drives, VFDs, in the oven. One leg of line power is connected to the common terminal of the CV drive relay from TB22. When 12 volts DC is supplied from the control board to energize the CV drive relay, the relay contacts close, and line power is supplied to terminal board TB26. Mounted forward of TB26 is a green ground terminal block, TBGND. Moving to the right side of the electrical chassis are the variable frequency drives, or VFDs. The VFDs are numbered at the factory to correspond to the chamber that they are associated with. Within this cable are the line power and ground wires. You will note that one of the wires is capped off and not in use. The 4 additional wires within the cable are connected to the control board and serve as the control and feedback communication wires. Warning: the VFDs do not have any serviceable parts inside of them and use very high internal voltages, so they should not be opened up. The other cable from the VFD is connected to the blower motor. Within this cable are the pulse width modulation (PWM) wires that control the rotational speed of the motor, and the Hall effect sensor (HES) wires that provide motor speed information back to the VFD. If you are troubleshooting a convection blower, measure the DC voltage across the yellow and orange wires at the communication cable connector on the control board. The control board sends a 2 to 5 volt DC signal to the VFD as the command for motor speed as required in the recipe. If the motor speed required is 100%, the voltage should be 4.4 volts DC, and at 20% motor speed, the voltage should be at 2.5 volts DC. You can check the motor speed feedback signal by measuring the frequency across the red and blue wires at the connector on the control board. With your meter set on the frequency setting, 100% motor speed should have a measurement of 778 Hz, and at 50% motor speed, the measurement should be 530 Hz. This completes the convection blower component identification video.